Imagine a single metal so powerful it can light up an entire city, or erase it in a single flash. This is uranium, the most dangerous and valuable element on Earth. It's a substance that holds the promise of limitless energy and the threat of ultimate destruction. Today, we're going to pull back the curtain on this controversial element, exploring its incredible power, the global scramble to control it, and the profound moral questions it forces us to confront. Is uranium our savior or our downfall? Let's find out. First things first, what exactly is uranium? If you were to hold a piece of it, which, by the way, I strongly advise against, you'd find it's a surprisingly heavy, silvery white metal. It's a natural element, part of the very fabric of our planet, found in trace amounts in rocks, soil, and even seawater. For billions of years, it sat there, mostly unnoticed. But in the 20th century, humanity unlocked its secret, radioactivity. This isn't the kind of radioactivity you see in cartoons, making things glow green. It's a subtle, invisible energy that uranium atoms release as they slowly decay. Now, here's where it gets interesting. Most of the uranium you find is an isotope called uranium-238, which is relatively stable. But mixed in is a tiny fraction, about 0.7%, of a different isotope, uranium-235. And this, my friends, is the superstar. Uranium-235 is what we call fissile, meaning its atomic nucleus can be split apart, releasing a colossal amount of energy. This process, known as nuclear fission, is the magic behind both nuclear power plants and nuclear bombs. It's this dual nature that makes uranium so fascinating and so terrifying. It's not just some obscure metal. It's a cornerstone of modern technology, a driver of international politics, and a symbol of humanity's greatest scientific achievements and its most devastating failures. From powering our cities to fueling nuclear submarines that patrol the deep, uranium is silently shaping the world we live in every single day. To truly grasp the power packed inside this metal, let's talk numbers. Picture a small pellet of enriched uranium fuel, about the size of a gummy bear. That tiny pellet can generate the same amount of electricity as nearly a ton of coal, or 150 gallons of oil. Now scale that up. A single kilogram of uranium-235, if fully utilized, can produce as much energy as 3 million kilograms of coal. 3 million. That's enough energy to power thousands of homes for an entire year. This is why it's sometimes called the metal of 1,000 suns. It's an almost incomprehensible level of energy density, a pocket-sized star waiting to be ignited. Inside a nuclear reactor, this power is harnessed in a controlled chain reaction. Neutrons bombard uranium-235 atoms, causing them to split. This split releases more neutrons, which then hit other uranium atoms, creating a self-sustaining cycle that generates immense heat. This heat boils water, creates steam, and spins turbines to produce electricity, clean, carbon-free electricity. It's an elegant and incredibly efficient way to generate power. But with great power comes, well, you know the rest. That same chain reaction, if left uncontrolled, becomes an explosion of unimaginable force. This is the principle behind a nuclear weapon. Instead of a slow, steady release of energy, you get it all in a fraction of a second. The atomic bombs that were dropped on Hiroshima and Nagasaki during World War II contained only a few kilograms of fissile material. Yet they unleashed a destructive force that leveled cities and changed the course of history forever. The power within uranium is a true double-edged sword. In one hand, it holds the key to a clean energy future. In the other, the means for our own annihilation. This paradox is what makes the global story of uranium so incredibly compelling. Because of this immense power, it's no surprise that uranium is at the center of a high-stakes, often clandestine, global race. This isn't just about mining a metal, it's about acquiring geopolitical influence, national security, and strategic dominance. Think of it as a global chess match where uranium is the queen. Nations with a secure supply of it can power their economies and project military strength, while those without it are left at a strategic disadvantage. So, who are the major players in this game? The world's leading uranium producers are countries like Kazakhstan, which alone accounts for over 40% of global production, followed by Canada and Australia. These nations hold immense power, as they control the primary source of the world's nuclear fuel. Their mines, often located in remote and desolate landscapes, are some of the most heavily guarded industrial sites on the planet. Then you have the major consumers, countries with large fleets of nuclear reactors, like the United States, France, China, and Russia. These nations are constantly seeking to secure long-term contracts and diversify their suppliers to ensure their energy grids remain stable. But the story doesn't end there. The real intrigue lies in the shadows, with nations that are trying to develop nuclear programs, sometimes in secret. Countries like Iran and North Korea have been at the center of international disputes for years, with the world watching their every move, trying to determine if their uranium enrichment activities are for peaceful energy purposes or for developing weapons. This makes uranium a flashpoint for international tension. It's a resource that is tracked by spy agencies, debated at the United Nations, and guarded with military precision. It's more than just a commodity. It's a symbol of national ambition, a source of deep-seated fear, and a constant undercurrent in the complex dance of global politics. But the pursuit of this powerful metal comes at a steep, often hidden cost. The glowing promise of nuclear energy casts a long, dark shadow, and it often falls on the communities and environments where uranium is mined. The process of extracting uranium from the earth is far from clean. It involves digging up vast quantities of ore and treating it with powerful chemicals to isolate the uranium. This process creates enormous piles of waste material, known as tailings. These tailings are not just ordinary dirt. They are radioactive and contain other toxic heavy metals. For decades, these tailings were often left exposed to the elements, allowing wind to carry radioactive dust into nearby communities and rain to wash contaminants into rivers and groundwater. The consequences for people living near these mines have been devastating. Studies in regions with a long history of uranium mining, from the Navajo Nation in the United States to former Soviet bloc countries, have shown elevated rates of lung cancer, kidney disease, and other serious health problems. It's an invisible killer, a silent poison that can linger in the environment for thousands of years, contaminating the land, air, and water that people depend on. Even after a mine is closed, the danger doesn't disappear. The cleanup, or remediation, of these sites is an incredibly complex and expensive process that can take decades. In many cases, the companies that profited from the mines are long gone, leaving governments and local communities to deal with the toxic legacy. This is the tragic paradox of uranium. The clean energy it produces in one place can be directly linked to the contamination and suffering of another. It forces us to ask a difficult question: what is the true price of our power? And who is being forced to pay it? So, where do we go from here? What does the future hold for this metal of immense promise and peril? As the world grapples with the urgent need to transition away from fossil fuels and combat climate change, nuclear power is making a surprising comeback. After decades of being viewed with suspicion, particularly after disasters like Chernobyl and Fukushima, a new generation of thought leaders, scientists, and even environmentalists are taking a second look. They argue that modern nuclear reactors are safer than ever and that nuclear power is one of the few sources of energy that can provide reliable, carbon-free baseload power 24/7, regardless of whether the sun is shining or the wind is blowing. This potential nuclear renaissance means that demand for uranium could soar in the coming decades. New technologies, like small modular reactors and even fusion power, could further change the game, making nuclear energy more accessible and safer. If this happens, uranium could transform from a controversial element into a critical lifeline, a key ingredient in our fight for a sustainable future. But the fundamental dilemma remains. The same technology that can power our green future can also be used for destruction. The more uranium we mine and the more nuclear material circulates around the globe, the higher the risk that it could fall into the wrong hands. The challenge for humanity is to harness the incredible power of the atom while keeping its demons safely locked away. Will uranium be the key to our long-term survival, or will it be the instrument of our own undoing? The answer isn't written in the stars, but in the choices we make today. Uranium remains what it has always been, the metal that powers our world and haunts it. Thank you so much for joining me on this deep dive into the world of uranium. If you found this journey as fascinating as I did, make sure to hit that like button and subscribe for more content that explores the science and stories shaping our world. I'd love to hear your thoughts in the comments below. Do you think nuclear power is our future? Let me know, and I'll see you in the next video.